I'm Matthew Umberger, Associate Principal and Managing Director of R&D here at Apex Engineers. I'm one of the original engineers that founded the Denver office, and I spent 12 years seeing what it's like to deliver high-quality structural projects to our clients on time and on budget. A large portion of what the engineers do doesn't require a structural engineering degree. Repetitive calculations, manual updates, and transferring information between separate models that verify something that the engineers already mostly knew. And then to do all of that over again on the next revision or the next project. So we built a team to fix that. Our R&D team is small. 2 engineers who taught themselves to code, a design technician, and a software quality assurance engineer. No outside vendors or consultants, just Apex employees who decided the tools that they needed didn't exist, so they decided to build them. So what did that produce? Over a 5-year period, we produced 4 powerful tools that help the engineers at every stage of the project. First, a project manager app. We saw engineers doing repetitive tasks like copying and pasting between Word documents and Excel files, and realized we could do this much better by collecting data in a central place and passing it through. So repetitive tasks like data entry, document creation, now is handled in one place with our project management app. So the next thing we built was the custom Revit plugin. 90% of our work is in Revit, a powerful tool in its own right, but not tailored to our needs. So we built dozens of custom tools that allow us to speed up repetitive tasks like renumbering details or organizing details on sheet, modeling windows and opening families in the same location as the architectural model, or QA/QC things like checking for overlapping schedules on a sheet. The next thing we built was the Apex Wiki. Apex has many engineers with decades of experience, but transferring that experience is really difficult. So we prioritized capturing that knowledge in one central place so that every engineer at Apex can leverage that knowledge. We've taken it even a step further. As the company has started to use AI tools, we've given access to our company knowledge base so that as these tools are working with our engineers, they have access to that same company knowledge. Which takes us to the analysis layer, which is what we're here to talk about today, the Apex Member Designer. Often, through the lifecycle of a project, engineers are working with multiple different software solutions to get the analysis and then transferring that information back to Revit. So we decided, why not use Revit as our single source of truth for design and documentation? The goal of the Member Designer is to do structural analysis inside of Revit. That means one source of truth. As walls move, as beams shift, as openings get bigger or smaller, the engineer is given real-time feedback on their design. The Apex R&D team is a 5-person team inside a 50-person firm. We've already built software that we never thought we could, better than anything we could find on the market. And that's given us the confidence that we can build anything. And from here, the sky's the limit.
I'm Jeff Bloss. I am a structural engineer and associate at Apex. And I've been on the R&D team since the very beginning. And my role is largely the software architect and helping to make some of the design decisions to help build out the products that we have internally.
Hi, I'm Linda Estrella. I am a structural engineer that turned coder and largely oversee the C# side of things. I've also worked alongside Jeff on the Apex Member Designer. And today we're going to walk you through the Apex Member Designer on a real project.
This demo project we're about to show you is based on a very real project that is going to be built in downtown Kansas City. It was submitted for permit in May of 2026. And what it is, it's 5-story multifamily project going to be built over a 1-story of PT podium.
Here's the structural model. As you are modeling out the building, the software is actually automatically sending over geometries and whatever relevant information that we need for the design aspect. Once that's modeled, the designer will, or the engineer will come in and apply loads to it. And as you apply loads to each of the walls, it's automatically designing with all the information that is already pulled in on the fly.
As you can see, every wall on the project has a color. That color helps cue the engineer in on where the wall is on its code check status. So if it's like a blue or a green, that means it's passing, and to what degree is it passing. But if it's red, that lets the engineer know that the current design status is actually it's failing. Something in that particular element is not passing code. So in this particular case, I have a wall that is red. So I simply click on the wall and the detail report pulls up. The detail report gives us a ton of information, all of the nitty gritty that the engineer is going to need to be able to determine what is going on, how is it not passing, and they can react accordingly. In this particular case, you could see for this wall, what we actually built up in the background is a complete finite element model of every single stud, top plate, bottom plate, all of the jacks and kings and the header, all of that stuff is built. And the engineer has seen that. That's what we actually use to design every single one of these members. In this particular case, the header is the failing member, and we can see exactly where it's going on if we click on all of the details about the header. And yeah, and that makes it pretty easy for the engineer to know, oh, the header's undersized for the particular loading. Let me bump up the header size and watch the detail report reflect that. You'll see it update in real time. Now, the real advantage to this for our clients is that we're actually designing every single wall, which unfortunately, that's not industry standard. Industry standard is you pick a handful batch of walls and you pick those as worst case and you design those. Because as you can see from the detail reports, there's like a lot of information that the engineer has to go through and check and all the things. But in our case, we actually do design everything so that we can fine tune the design to exactly what that load is as it needs to be. We don't have to upsize everything because a couple walls are actually heavily loaded. We can design it exactly as the load requires to keep the project more efficient, make it more buildable, help the contractor out, help the owner out. Really, it's a win for the building overall.
Now that we've seen how the engineer reacts to the member designer through the design process, now let's talk about how the member designer can be helpful in reacting to external changes. As we know that our projects are typically not always static. Changes are inevitable for various of reasons. And so, what would typically happen is an engineer would then have to update Revit, then go to their engineering software and make sure that the updates are coordinated in those softwares, and come back and change the actual beam or whatever it might be. But now all you have to do is update Revit, and the member designer handles the design in the background for you. And again, you're getting live feedback all in one place.
As Linda just alluded to, the models aren't static and designs happen. That happens to change quite regularly throughout the whole process for various reasons. One of the changes that happened on this project was the architect was hoping to shield some RTUs because it was a request from the client. And he asked me, hey, can you update the parapet heights from 2 feet up to 4 feet? Is that going to blow things up? And typically what that looks like is the engineer has to go back to a separate software, update those calcs, make sure it looks good, then go back over to his model if it is going to be okay. But in our case, we simply update our model and we change our parapet height up. We drag it from 2 feet up to 4 feet, and we can watch it update in real time. And then we can send them a message right back. Hey, it's okay. Here's what we have to do. Done. Much quicker turnaround, quicker feedback for the client to know, is this okay? Is this worth the added cost for maybe possibly some, reinforced studs or something like that? Just helps keep the design team moving by having the real-time feedback.
On top of being able to get efficiency gains from designing every single member in the project, we're able to zoom in and get even more efficiency gains from the individual member by leveraging code provisions that are allowed to us that even other softwares aren't even taking advantage of.
Another example that comes up on a project is when the architect changes some opening sizes. On this particular example, we have a stack of perfectly aligned openings for the full height of the building, which is very efficient and easy to design. The problem is the architect often doesn't like that because it's kind of boring, and I don't blame him. In this particular case, the architect wanted to shift these nice 5-foot wide openings and shift them to a 2-foot wide opening, but not every single level. Actually skip a level. And that, from a structural standpoint, creates all kinds of new load paths and that we have to account for, which if I'm doing this the old way, like the industry standard way, this is going to take probably a couple hours, honestly, to track this down, make sure all my calcs are updated, then update my Revit model. But in our case, we just simply have to update the Revit model. And we watch how it all shakes out, see what headers are failing and what we need to bump up to design the new load path.
Because Apex owns the entire process, that means we can connect these software together. We can grab loads from our project management app. We can push information to our Revit plugin QA/QC panel that gives you high-level information about your project. That's one of the benefits of us developing the software ourselves, not relying on third-party vendors.
As we step back from the project, let's think about the impact this program has for all the stakeholders involved on every project. We have the owner that cares about the cost of what is built. We're able to efficiently design every single member, thus saving them money at the end of the day. The architect cares about the aesthetics. Because we can quickly give them a turnaround on what works and what doesn't, we give them the flexibility to be able to change layouts as they please. The contractor cares about the coordination of the drawings. Because we have that single source of truth, that's going to be truly what needs to be built because we built what we show in our drawings, or we design what we show in our drawings. And then the structural engineer cares about the safety of the building. And because we are able to design every single member, we have that quality control built in automatically.
At Apex, we have a mission to deliver buildable, logical, efficient structural solutions. One of our core values is to use cutting edge technology to continuously improve our processes. What you saw today embodies those values. We're a small firm with big ideas and a drive to build, and we're just getting started.